Hello viewers, and welcome to a new third live stream in my series where I'm creating a PCB from scratch. In the first video, which is linked here, KiCAD project from scratch, KiCAD project from scratch, number 1, we created a schematics, and in the second one, and a basic PCB. In the second one, we created the entire PCB, and we finalized the PCB in this video. Well, okay, I should say that while I was creating these live streams, I was in touch with one of the Chinese manufacturers of PCBs and assembly house called wait, I don't have my, hang on a second, I don't have my can I reload this page? I don't have my chat history. Let me just sort that out. Something went wrong. I can't see my chat history. Okay, that makes it a tiny little bit easier for me because let me no, I want to sort that. Switch, maybe it's here. Content, live. Am I still live? Oh, I think I have it. Maybe have it there. Oh, now I have it. So, and we are still live. So I think it's working now. So I can see the chat, but like last time, it is way over there. So I might not see the messages early on. Where was I? Yes, I was talking to a Chinese manufacturer, and they actually agreed to sponsor this video. So I think what is going to happen is today we're going to put in the order, and then they'll probably give me some discount, and I will have it shipped down to me, and then I'll do a couple of follow-up videos where I'm actually using this board. Just a quick recap of what the board is. I mean, it's not particularly useful, I must agree that, but essentially it contains an I2C I/O expander. This particular I/O expander called AW9523 also contains LED drivers. That means they can control the current for up to 16 LEDs, or in my case, 5 RGB LEDs. So the board contains this I/O expander and 5 RGB LEDs. And that is what we created. Now, I have probably done a few changes since the last time you saw me doing this, and I am going to go through those changes now. So in the schematic, I don't think I changed very much. Yes, I did. I changed the pull-up resistor for the reset line. Now what happened was I was reviewing and reading the data sheet, and the data sheet clearly states I had a 100K resistor here before. The data sheet states that the reset pin is internally pulled down with a 100K resistor. So with 100K resistor and a 100K resistor, that is a voltage divider that will divide the VCC into half. So that means the reset line will not be high, it will be floating somewhere in the middle between, so at 1.7 volt or thereabout. Which is not a good idea, probably. So I lowered this to 10K. That means that in total, it should be up around 3.1 volt, if VCC is 3 volt, 3.3 volt. This will actually work with 5 volt as well. It doesn't really matter what you feed this with up to, well, I don't know. At one point, this pull-up becomes so aggressive on the lines that it will no longer work. So anyway, that is the changes I did in the schematics first and foremost. For the PCB, I actually made it a little bit wider. It was a bit tight over here. I didn't have space for silk screen, and over here these were up at the edge, and it was hard to, I mean, this over here, essentially there was no ground fill on the outside, so I changed that a little bit. And this is how it looks. Everything is aligned, everything is okay. It passes, it should pass. It never, I mean, now I'm live, it will fail, obviously, but let's try. It should pass with no errors and no warnings. So that is the design rule checker. So it lives up to the design rules. Let's look at the 3D briefly. Let's look at the 3D. I managed to put silk screen on top as well, and I added a little bit on the back. I will get back to that. No, essentially, JLCPCB, which is the one I'm going to use, you can put a code which is JLC in caps 4 times. So JLC, 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 JLC. That will be replaced by a batch number at JLC's factory. You, if you don't include it, they will put it in themselves somewhere. But if you include it, they'll put it in at that spot. So that is just to control that. Otherwise, you would risk they put it here or something like that. I don't want that. So this is essentially the board as we are going to order it. There is one step more if you order from someone like JLCPCB, and that is in the schematics. Now, JLCPCB will need to know which part to use. So if we go to a browser, and this is slightly time consuming, if you go to jlcpcb.com, now there's actually more. Let me talk you through this, because this is quite important. So now we are on JLCPCB's main website. They will have a holiday, May 31st. Order can still be placed. That is actually today. So they're having a holiday today. Hi PCB, JLCPCB, but that's okay. But there's a few things in here that are really important. If you remember from the first video, I was setting up the PCB parameters to a certain number, and I explained that these were quite old and I could probably have made them smaller. But if you go in, the single most important page you have here, if you're going to order, is the one called capabilities. On this page, JLCPCB will explain what they can do. They can do 1 to 32 layers. They can do FR4, which is a standard PCB. They can do aluminum core, copper core, RF PCB. I don't know what that is actually. I don't know what RF is, but something else. But they also have down here maximum dimensions, minimum dimension. The important thing is the traces. Here you have a minimum space and a minimum trace width. If we look at the minimum trace width first, on a 2-layer, we are doing a 4-layer board actually, so we are down here. We can see that the minimum trace width, we are 1 ounce, so we are up here. We can actually do 3.5 mil. Remember, I was setting mine to 6 mil, so I can actually make it, the traces and the distancing, I can make them way smaller than I'm actually doing, almost half. But they can still do the 6 mil, of course. So that is, remember, I made all my traces 9 mil, so I am well within what they can do there. You also have the vias, which is essentially plated through holes, and there's a recommended size and an absolute minimum 0.18. I was doing 0.35, I think. Let me check my PCB. I think I'm doing 0.35. Where is that configured in the board setup? Predefined sizes. Nope. Constraints. Nope. Net classes. Here. And I need to switch my settings to millimeter to understand that proper. So we are at 0.3 via hole with a via ring of 0.7. So in other words, we are well within the specifications of what JLCPCB can handle. So all is good there, but before you are even considering ordering a PCB, you must go through these settings and see that everything, and it's a good thing to understand what the capabilities are for JLCPCB. I also have some capabilities with assembly and single and double-sided they can do, and this basically goes through what the specification for the assembly is. Should know that. The other page that is extremely important here are, where do we have that? Resources. I don't know where the link is. It used to be up here, I think. But I've been there so many times that I just type it in. If I type JLCPCB, you'll see it comes up here with /parts. I need to find the link. But this is the part library that JLCPCB have. And of course, if they are to find the components and put them on a board, they need to be able to know which parts we are talking about. So the way that will happen is you search on this. So if, for example, we want the AV9523, we want that one, we can search for that and they will come up here. This is the one they have in stock. They got 18,000 right now in stock of this one. And what you need to know is the JLCPCB part number, which is here, starting with a C, ending in 77. Talking about parts, I should briefly mention that JLCPCB is owned by a mother company. I am not going to try to pronounce that because it's Chinese. The same company actually own, and I have shown this before, the Chinese equivalent of DigiKey or Mouser or Element 14/Farnell. They have their own Chinese parts supplier, and they have everything. They have a lot of parts you will not be able to find on DigiKey, the special Chinese parts, but that are a lot cheaper. And in here you have 9523. LCSC have a lot of parts that you will not normally find on the JLCPCB, but you can still order them, and I think you have to prepay the parts. Then they will put them in their library for you to use. So here we have the same part on LCSC and LCSC, and you can see the same part number. It is the LCSC part number C14 ending in 77. 7. So same parts and same, actually same company, but it's not the same location low. So there's a bit of timing if you need parts from LCSC. It's not instantly available in the library of JLCPCB. So in our schematics here, no, schematic is there. Each part will need a part number. And the easiest way to do this, or if you go in and you edit a part, press E. The properties, simple properties or part properties, you can see I simply add a field down here, which I call LCSC, and I add the part number. Once you did that with 1, you can go up here in Tools, Edit, Simple Fields, and you have over here, you can say which one you want to see and which one you don't want to see. And over here, it will show all these numbers down here. So you need to make sure that each and every part have a part number. So if we take, for example, our 100 nanofarad capacitor, which is there, you have a part number over here, and we can go over to the library here and search for that part number to make sure that it is the right one. And you can see, first of all, it's 100 nanofarad 0603, which is what I wanted. Capacitor. You can also see another thing, and this is also relevant, and you should be careful with that. JLCPCB have something they call basic parts, and they have something they call extended parts. Essentially what is happening at the factory is they have a long line of pick and place machines, and some of those pick and place machines are preloaded with companies with components that everybody is using. A 100 nanofarad 0603 is probably one of the most used components at all. It costs 0.2 cents a piece if you buy one. They are very, very cheap, and they use a ton of those. So they don't need to set anything up to use this component. They will just, when it runs to that machine, they will just pick the one that is there. So these basic parts you can use, and you will pay pretty much what you have over here and nothing else. There's no wastage when they load components into the machine. The rest of the components they will need, if we look again at the AV9523, if we look at that one, you can see it's an extended part. That means that it is not already loaded into any machines in their production line, and they will need to specially load it up. They charge a one-off fee of $3 per extended component on your design. Doesn't matter whether you make one PCB or you make 100 PCBs, they'll charge $3 to make that change in their setup. So you can save some money if you have, like, if we look at this, we have a total of, that's not a component, 1, 2, 3, 4, 5. We are not putting 6, 7, 8. We had 8 different components. You can see if we actually had to pay the $3 per component, that would be $25, $24 already. So it's a lot cheaper if you can, at least small quantities. It doesn't matter if you make 50, but if you are making small quantities, it's a good idea to make sure, check if you can find a component which is actually a standard component, basic component they call it, because that's already loaded into the machine. So you got to make sure that all these part numbers are right, and trust me, believe you me, this is where mistakes are made. I can't count the number of times where I accidentally put in a wrong part number, and I mean, and had to change the part manually later. You need to double and triple check all your parts. Now, as you get more experience, I usually copy components from another. I have a shared library between projects, and one I put all these in. I don't have to double check anymore 100 nanofarad. I did have to double check the 1 microfarad, but it's not a size I use very often. But that's how, and of course the RGB LED. So that's pretty much it. Make sure you have all these components defined. Make sure you are using the right footprints, and double check and triple check. Remember, in my last video, I actually talked about my own personal review process, where I go through this. I will review it, and then I'll make changes, and then I'll leave it, and the next day I'll repeat. And I will not order until I've been through this without any changes. And I actually did go through this last night and couldn't find anything I wasn't happy with. So I feel I'm ready to order now. So next step up is to create the ordering files that JLCPCB needs to process an order like that. First step is in the schematic editor. I usually, this is pretty much a manual process. Oh, by the way, let me say, and let me state this clearly, I know that there is a plugin for KiCAD that can generate the ordering files. I'm not using it, and I will not be using it, because I have this process nailed down. I like to do it manually because it's sometimes I catch an extra error going through the process. So that is what it is. First step I do. So for later reference, I'll go down to plot. I will plot me an SVG, which I use. For example, I'll upload that on the website. If we go over here, I have the schematic, but it includes the revision, so I will keep track of the revisions. So I will plot that SVG, plot all pages, and it creates the I2C underscore let SVG. Done. That is not used for JLCPCB or KiCAD anywhere, except for me to have a later reference. Next step, under Tools, you have the Generate Bill of Material. And there is some variables you can tweak in here, but essentially it's a comma-separated file where you have the components, and most importantly, it includes that column called LCSC, which JLCPCB is then using later to find the components. So, okay, I have that file. That is pretty much all I need to do in the schematics. I'm done with the schematics. So let's go into the PCB editor. Now I need to generate the files that JLCPCB uses to produce this. Let's do the PCB first. So we go in to plot, and we create a plot format called Gerber. Now, I would usually put these in an output directory. I'll show you. So I created a directory called Rev A, because I'm doing revision A. Take a wild guess and put it down in the comments. There is a viewer here say he's going through my STM32 playlist. He's not ready for PCB design. Well, and he wanted to say thanks, but he's not ready to do PCB designs. Oh, you will be, and it's great fun. So hang on and see what is happening. It's this project, I should say, I deliberately kept it simple and stupid. I mean, this is about as simple as it gets, and that is deliberate. Anyway, back to this. I need to create my Gerber files, and essentially Gerber is a standardized format that all these PCB manufacturers use, and you basically create a Gerber file for each layer, so it's a bunch of layer files. You also have a drill file in here, and we need to do that separately. I put it in there as well. It's called Excellion file. That's also a standard file. So I will start by generating the drill file, and then I'll do the plot. And you can see it fills, it generates all the GBR files for the different layers inside Rev A. So that is it. We now have the plot files that is being used. That leaves one file we need to do, and that is under fabrication outputs. Fabrication outputs. We need the component placement to tell JLCPCB where the different components are placed. Again, we're using comma separated values, and we put that in Rev A and include just standard settings, really. Generate. So we have this top and bottom file. We only use one of them because this is single-sided. So that is about it. Now we need to do a little work. Now, I don't care what you use, but sort of by tradition, morning from Harry, there is a tradition that the Gerber files, to keep track of them, you basically create a zip file with them. So the first step I'll do is I'll create a zip file called my project name zip, and I will basically take everything in that Rev A folder and put them into that zip file. So I'll have a zip file with all my Gerbers and all my drill files. JLC will figure that out, how to use it. So I create that zip file. I will then, next step, again, to be able to keep track on it for later, I will take my I2C LED CSV and I will go into a BOM CSV. I will make a backup of that file called I2C project name underscore revision name underscore BOM CSV. I'll do the same with the position file. So I will copy Rev A, it's called top CSV, and I will copy that into a POS CSV. So I have a POS file and I have all the revision files. I should do this over here, but there's not much more to be done. So we have it here. Now we now have all the files that we need to order from JLCPCB. So we can go back to this page. I can sign in. I didn't do that before. I normally do that. So let's sign in. I use Google to sign in to JLCPCB. We are now signed into JLCPCB, and we can click the order now. You can also click down there, but that's okay. So now we start a new order at JLCPCB, and the first step is to upload the Gerber files, because JLCPCB are analyzing those files. Wait, I need to be in source, I2C LED PCB. This is my folder where I have all my stuff. So remember, I was creating that zip file, I2C underscore LED underscore a.zip. So we will upload that zip file to JLCPCB. There was a very irritating period about 2 years ago where this one would fail approximately every third time you did it, so you had to do it again. But they seem to have fixed that problem, and the last times I've done it, there has been no issue. So you can see it analyzes, it detected a 4-layer board of a certain size, and that is it. So they automatically click the 4-layer and put the right size in. Now, I want more than 5 of this one because I plan to give some away to my fantastic viewers. More on that later. So let me do 20 of these. You can see now the price actually starts to change over here. It was, I think, up to 10. No, 2. If you do 2, you get them for $2 for 5. But once I get up to 20, it becomes a little bit more expensive. I think they need to add some rails, or I don't know. It becomes a little more complicated. So I get 20 for $25, a little more than $1. So it is actually more expensive than actually just doing. Why does it jump up actually? It's an engineering fee they put on, a special offer. So the engineering fee, I don't know why okay. Anyway, doesn't matter. I want 20. So, so far the order is $25 for these PCBs, and they will pretty much come as they look here. There's one more change. Remember, I put that JLC label on the button. We need to select that, and we do that down here, mark on PCB. We can say order number, specify position. If we do that, they will print the value in this field. Another thing I usually check here is you can see that white in the that is the holes. So that means that the drill file has been interpreted, because the drill file is not actually part of the Gerbers. It's a separate file, but if I have those white ones, the drill file is definitely in that zip file, and they found it and they knew what to do with it. So that is all good. If the holes were not there, go back and check your files. So I'm pretty happy with the PCB. There is a gazillion options. Oh no, I am going to make a change here. Default is 1.6 millimeter thickness. I generally, for small PCB like this, they look clumsy if they are 1.6. So I go down to 1.2. That is the smallest you can make without paying extra. If you go down to, say, 0.8, you'll see that it gets quite significantly I'm full of crap. It didn't get more expensive. Anyway, let's go back to 1.2. Now it's 30. What did I do? Surface finish. I must have. It's went to lead free. I don't care about lead. I'll go back to that one. Can I do? Oh, it's okay. Leave it there. I know this will work. You can also select another color of your solder mask, but you will usually end up paying extra for that. So that will cost $16. No, I don't care. PCBs are green. So let's go back to the green one. Green. I'm not a big fan of black boards. It becomes hard to see. It looks good, but it becomes hard to see what is going on if you are trying to troubleshoot it. So I went through this. There is a lot of high spec options down here. I just selected this. So, but this pretty much covers the PCB. If you just want a PCB, you can save this to the card right now. And in my case, that would be 2 or 3 days later. I would have it in my. It would be delivered to me. So all good. But we want them to assemble and put the components on, and this is a tricky bit. So I basically select this option down here to have them do the assembly. Now, the first, normally they would do top side or bottom side assembly, one-sided, at least in the cheap ones. So I have to tell them which side I want them to put the components on. JLCPCB don't really care what is up and down. They will just do them in one way or another. Now you have economic, standard, and they will list the difference. If you can get away with it, just go for economic, but certain options you change, they will change down here to standard. It is quite a lot more expensive if you go standard. That was $10. As I don't know. The board becomes more expensive. That is 70. I don't know. Anyway, assembly top side, we have selected that already. So this is pretty much all we need to do. Now this button, which was called checkout before or save to cart or something like that, have changed to next because there's a few more steps we need to go through now. And this is where it gets complicated. First, it shows us the PCB, which is the last part of the order here. No, it's not. It's an economic economy, I would have called it, but never mind. Assembly on the top side, and I want 20 of them. Oh, you can switch over here. You can switch to see the button. Next, now we have to upload the bill of material, BOM, and positioning file. So we go in here and we select our BOM CSV and upload that to them, and then we select the position CSV and upload it to them. Let's try to process that. Now you will almost inevitably I got a complaint from YouTube. Is not receiving enough data, but well, not much I can do with that if there's a bandwidth issue. Okay, I process these BOM and CPL files. Be prepared to get some errors here because oh yes, okay. Problem number one, these will need to be hand edited on small scale. So I will go into a POS file down here. You can see that first of all the header. I don't know why JLCPCB or KiCAD have not fixed that, but they don't like these titles. They want designator. These POS X needs to be mid with a space X and mid Y. Rod needs to be rotation and side needs to be layer. So I save that and I try to upload it again. Let's see if they like it better now. Designator mid-X, mid-Y, rotation layer. Wait. This is what happens when you do live streams. I had this working perfectly before. Actually, let me cheat. No, I won't. So let me figure this out. Top. Designator. Mid X. Mid Y. I'm sure all of you, which is one or two. Oh, Julius is back. Mid-Y rotation layer. Let's see if should be okay. Let's try to upload that POS file again. It would be slightly embarrassing if I actually ended up having to give up. Okay, no, it worked this time. So error. The below parts won't be assembled due to data missing. AD0, that was the jumpers. They don't exist in the component. That's fine. I don't need any components so for the jumpers, right? So we just continue. Ignore that error. So now we get the bill of materials. So JLC found some parts. They couldn't find a part for a connector. No part selected. It's okay. The connector, let's just remind ourselves what we are talking about here. 3D viewer, which is basically the header over here. I'll solder that in manually. I don't want them to solder that in. So no problem leaving that out of the ordering file. No part selected. The capacitors, they found some, I expect that to be 1 microfarad, and it is right there, 1 microfarad. So that looks, and the size looks right. It will be caught later. They're all selected. They all found, and basic, extended. So I will need to pay $3 for the extended for the RGB LEDs, and $3 for the GPIO expander. So that will in totally be $5 for. Remember, we are doing 20 here. I'm actually getting 105 RGB LEDs at $1.70. It's almost silly. So let's click next. One part not selected, which is the header. I'm happy with that. So next, project has unselected parts. Just a warning. Do not place, I tell JLCPCB. I'm okay. I'm aware of it. You don't have to do anything. So now it will come up with, and this is where it becomes a little bit tricky, and you really need to spend a bit of time on this. For some weird reason, which I have never figured out completely, there is some writing about it. Some components, the rotation of the component, KiCAD, when you export from KiCAD, does not get right. So you have to double verify this. For example, you can see here my U1, JLCPCB would put pin 1 over here, but our schematic, our PCB, we need it over here. That means we need to rotate U1 clockwise. So we go into our POS file here, we find the line with the AV, and you can see at the end here, it actually rotated it 90 degrees for some reason. That's JLC, that's KiCAD. But if we move that, that one should actually be correct. So just 0 degrees rotation on that one, it should be down here. The other one that goes wrong is typically diodes, or there you can see we have the plus up here, indicating that is the pin 2 actually. So we have pin 1, but 2 is down here. Remember when we were doing the PCB, I had to put the VCC into this pin. That is the one they indicate with a plus. So in other words, these all need to be rotated 180 degrees to be fit. So we go back to our POS file, we find the diodes, and they are all at an angle of, so we add 1/8 there. So now we have all the diodes, the LEDs, RGB LEDs, rotated by 180 degrees. Let's save this file, and now we go back to the ordering interface. We go to bill of material, we upload a new CPL POS file there, and we go through that step with the components again. They don't, so we continue because we don't need that. Here we have the components, the connector not selected, we're happy with that. Do not place that, we're happy with that. Now we should be back, and now all the components should have the right rotation. Let's start with the U1. It has been rotated, so pin 1. Their interpretation of pin 1 matches my interpretation of pin 1. So that's all good. The LEDs plus is down here where we are having our feet, so all the LEDs are rotated correctly. Of course, the capacitors and resistors over here don't really have a direction, so this is great. I saved the video so I can watch the whole thing later. Yeah, well, it will be there. It is in a playlist, actually. I have put it in a playlist. So once you're happy with this, and you need to check pretty much all the components, then we can go in here and click next. Sorry about that. So remember I was ordering 20 of these. So 20, the PCB will cost me $24. The the assembly, there's a setup fee, there's a stencil they need to make, and they need to, you pay for some components, $7.40 for 20, and extended components fee. Remember I had 2 components they needed to do, and I paid $1.82 for them to assemble my part. All in all, $50 for 20 of these, and all I need to do is, well, I don't know, you used to have to, let's call it DIY hobby, something like that. I don't know if you have to put this in still. There was they probably just pick a default, I would guess. Save the card. So now they will save this file to the card, and the order, all you need to do is pay, and they will start the production. Here we go. I now need to pay. I'll not go through this because I still need to figure out how much they want me to pay and how much they will pay. And I actually want to add, if we go into the, you need to, I want to add an extra order, add new item to this, because to me, if I pay shipping, whether they put 2 or 3 PCBs in the same box, it doesn't matter. The shipping is the same. So I can save a lot of shipping by putting more than one thing on an order. So that is the reason for that. But it is as it is. What will happen is, once I pay for this, they will check these, and you need to keep an eye out for your email, because JLCPCB, they're pretty good at catching mistakes and make suggestions for changes and stuff like that, and they will do that. So they will not start the production until they are happy that they can produce this without you complaining about it afterwards, and that is how it should be. Now, there's one more thing I do. Once I put in the order, like these files, in my GitHub, my folder here, I will have, remember I called all these _A_A's. These 3 files are the production files that needs to be handled, and I will add them. So I'll add everything to GitHub. I will commit. Oh, wait, don't stop that. I need to leave KiCAD. I don't want, it has some temporary files I don't want added. I will commit everything, and I will also add a tag called rev A. I'll push that to GitHub. Now it is saved forever. I won't lose it. And I will also push tags to GitHub. So now I can always go back and I can find the exact ordering files that I used for this specific order. I can see, well, I'll know exactly where to find them again. You will see if you go to GitHub, where did I create this one? Was it my personal? I think it's my personal. No, it was probably STM32 World, or was it? Oh, it's not there, so it must be my personal. There. Repositories. I'd see that. It's still labeled as private. So you guys don't have access. Let me change that right away. I don't really wanted this to be secret, so let's go down here. Where do you do that? It's a private project. Am I blind? I must be blind. Oh, I am actually getting blind. That's allow rebase. What am I missing? Is it up here or? Let's search for. Oh, this prepared change visibility. Here we go. Change visibility, change the public. I want this public. I have understood. Oh, I want my security key. Let me put that in. Here's security key. There we go. So now it is public. It should be public. Let's verify that. If I go over here, you can see, and inside PCB, ready to order, you will see you have those 3 files with _A, there, and there. And they are the 3 files you need to order this from JLCPCB. It's really that simple. That's all they need. So if you want to do this, if you go over to the page on Wikipedia, you have they give you something. I can't remember how much it is, but if you click on this banner, they will actually give you a coupon for your first order, and I'm sure you could almost get your first order very close to free if you if you decided to create 5 of these using my files. You will probably get away with this. How long as there is a message. This is before the internet. Yeah, that's okay. On Julius is right here that this is rare and valuable. Before the internet, very few people would have been lucky enough. However, Julius, I would argue that there's also an enormous amount of crap on the internet. And before the internet, if you actually found the material in a library somewhere, then you could be reasonably certain that it was of a good quality. I am absolutely scared, terrified how much idiocy that floats around on the internet. If you wanna convince yourself, try to Google, make a simple Google search how to blink a LED, and you will pretty much find one video out there that doesn't say use delay in the main loop, which is, I mean, any qualified engineer will know that is insanity, and yet that is what they all suggest. You will find one video that suggests you actually do it a little better, and that is my video, by the way. So give me a thumb up on that, or super thanks, or whatever you can think of. So anyway, we have created an order. We have created a PCB from scratch. We have created the design. We have created everything in probably what 3-4 hours of video streaming. I could probably have done this in a couple of hours tops if I didn't have to talk at the same time. So why did I order 20? Well, I mean, I thought it was cool. I have not decided yet, and I will read your suggestions. You can suggest in the chat, or you can suggest in the comments afterwards what to do with these. I don't really have any need for them, except I'm going to make a couple of videos actually using these with an STM32. But that leaves me with a bunch of boards. I can pretty much ship anywhere in the world for about, I think it's $10 or $12 or something like that. I can ship worldwide for that. So what should I do with the rest of them? One idea would be to have people give me a super thanks, which costs a bit of money, and then I'll do some kind of lucky draw and send some of these. I could also sell them flat out. I don't know. No, I don't want to do that. It's too much work. It's not worth it. Or you can order yourself on JLCPCB. I'm sure JLCPCB will be pleased and maybe give me a few bucks extra in coupons. I don't know. I have not actually thought this through completely. I just, well, these were so cheap, these boards, I might as well order 20 of them. Is there anything else I need to say? Save the video. Yeah, a lot of crap on the internet. I responded to that one. The order is here. Now, okay, I'll do them a favor. No, this is not, honestly, this is not because of JLCPCB alone. Yes, it is new that I talked to them about maybe sponsoring this channel a little bit, and because of that, I did agree to put a page on. But the simple fact is, I have used JLCPCB for the last 5-6 years, and pretty much every single board that you see on the STM32 World website, I have produced on JLCPCB. I don't like to solder SMD. A lot of them I can solder one, but I don't want to mount this stuff myself. I did. So I have created a lot of smaller projects with JLCPCB. This one was actually really cool because it have the jacks and they are also a standard component. And this was a really cool little project that do a USB to MIDI. So you get MIDI, you get control voltage and stuff like that out. So it's essentially it's not a synthesizer, but it's controlling a synthesizer. It can control a synthesizer from a USB channel. It's very cool. I did a cool thing. This is also something you should keep in mind. I actually, I think we can see it here. So I did a cover for that same board, which is basically just screwed in. So rather than actually doing an enclosure, I just have it sandwiched in a cover there to protect the components. Let's just use PCBs as enclosures. It's cheap to manufacture PCBs. So that is another way to do it. Play around with it. Creating PCBs is good fun, and when you finally get one you made, when you finally get one that works, I should say, it is immensely satisfying. So very good fun. So that's about it. Is there any comments I have not responded to? Okay. Michael Beavis, this project is cool. Yeah, I think I know who that is, and that's perfectly okay. It's cool. So yeah, that's about it. That's what I planned to say today, and that's I have another video I actually want to make today, so I'll get on to that. Sorry, STM32 related. So that's it. Have a wonderful rest of the day, and do give JLCPCB a shot. Check it out. Bye bye.